Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. This is the last question under May-June 2023 question paper. So it is under probability, right? So it's probably assessed on a grade 11 probability, actually tree diagram here. 10.1, it is what we call tree diagram. 10.2 to 10.2, it is a Venn diagrams. Then 10.3, it is a topic in grade 12, which we call what? Fundamental of counting principles. All right. Now let's look at the tree diagram. Now we are told that a group of people participated in a trial to test a new headache pill. So a new headache pill, all right. So now they tell us 50% of the participants received the headache pill. 50% of the participants received a sugar pill. All right. Now 2/3 of the group receiving the headache pill were not cured. So the first trial, it is the type of pill. The first trial, it is the type of pill. The second trial, it is whether the pill that you took healed you, cured you, or did not work. 3 divided by 10 of the group receiving the sugar pill were cured. Okay. So now the first information we have, it is with regards to the pill. So you have to take it. Remember, this is independent of that, but this depends on that. What do I mean? Your cureness depends on the pill that you take, but the pill does not depend on the cureness, whether you get cured or not. The pill does not care. Okay. So what happens? You have to draw a diagram for this one, and they say now represent the information on a diagram. Indicate on your diagram the probability associated with each. All right. So what you're gonna do, we'll do this. Actually, let's come here. Let's capitalize this space and say now. I'm gonna start first by branching the type of pill. Okay. So for headache pill, headache, I'm gonna say it is headache pill. For sugar pill, I'm gonna say it is sugar pill. You can use whatever, but as long that it's gonna make sense. Okay. For sugar pill, or I can say, since when it is pill, I can say this is headache, this is sugar. Then for cured, I'm gonna use cured. For not cured, I'm gonna use N, not cured. Okay. So this is what I'm gonna use to avoid writing long things. Now the first one, it is either you took the headache pill or the sugar pill. Then we branch it, whether you took if you took the headache pill, whether you get cured or not. All right, cured or not. Similarly to the sugar pill, it's either you get cured or not. Cured or not. Now they told us, please show us. They said now this is your tree diagram, but they said indicate on your diagram the probability associated with each branch as well as the outcomes. Now the outcomes are these. The first one that you might get, it is headache and get cured. Okay. The first one is that you might get a headache pill and get cured. The second one is that you might get a headache pill and not cured. Okay. Headache pill and not cured. The third one is sugar pill and cured. The third one is sugar pill and not cured. This is what the examiner required of us thereof. All right. Yes. Now 10.1.2 says determine the probability that the person chosen at random from the group will not get cured. So you want such that particular person will not get cured. But remember, before we arrive to not cured. It means you should start to whatever the type of pill. So it means what we want it is took the headache pill and not cured, or that particular person took a sugar pill and was not cured. So it was on random. We were not told which one to be specific was taken. So we're gonna use the probability thereof for both. So we're gonna use what probability that it is that this particular person is not cured, probability not cured. It's gonna be what whether that particular person took a what a took a pill. So it's gonna be probability of took a headache pill and not actually. Let me do this and not cured plus because it's this HN is the same as saying it is headache multiplied by not cured, right? Sorry, I have to fill up these things here. What is the probability that they took a headache? Remember, they said 50%, so it's going to be half here and half here. Okay, so this one. Okay, now 2 divided by 5 of the group receiving the headache were not cured. Receiving headache were not cured. Headache here were not cured here. So they say 2 divided by 5. But remember, I said the probability of something should be equal to 1. So the probability of this plus this should give me 1. So you can say 1 minus this is going to give you 3 divided by 5 for this one, the off. Then for the other branch, it will give you, they say now, where is it? 3 divided by 10 of the group receiving sugar pill were cured. 3 divided by 10 were cured. Where is that? This part. 3 divided by 10 were cured. It means when I subtract this from 1, I'm going to get 7 by 10 were cured. Okay? This information is very important to know for you yourself because they do not give you, but you should know as per definition is that the probability of something of an event should give you 1. So it's going to be probability of headache and not cured plus the probability of sugar pill multiplied by not cured also. So now it's a matter of just using substitution method thereof. I prefer using bracket because yes. What is probability of headache? Probability of headache it is half multiplied by probability of not cured when took a headache pill it is 2 divided by 5. Okay? 2 divided by 5 plus probability that took a sugar pill it is half multiplied probability that not cured when taking a sugar pill not cured it is 7 divided by 10. All right? Yes. Okay, or is it 7 divided by 10? Now it's a matter of just punching your calculator precisely there. You get something like 11 divided by 20, or you can approximate this to I think it's 0.55. All right, yes. This is how you get your answer. Then now let's move on to 10.2, the Venn diagrams now thereof. The probability of A is given okay. Probability of A is given as this, probability of B is given as that, probability of A or B is given as that. Now are events A or B mutually exclusive? Now they are mutually exclusive when what? We say events are mutually exclusive rather if the probability of A and B it is equal to 0. Okay, this is how this is when we say something it is mutually exclusive. So we are required to prove that whether the probability of A or B it is equal to 0 or not. Okay, so how can we do that? From our formula it says probability of A or B it is equal to probability of A plus probability of B minus probability of A and B. So what is probability of A or B? A or B it is 13 divided by by 20. All right. Then allow me to automatically subtract probability of A, which is how much? 2 divided by 5, and subtract probability of B, which is 1 divided by 4. Then this is what I get as my, I get negative. Is it negative? Let me see something. All right. Probability of A or B. Yes, that. Then let's see. Probability of A and B, actually. Let's just leave it as it is. Please punch this on your calculator. Or you can just divide by negative and say it is negative. Actually, you can just divide by negative and say this is going to be now negative, this is now going to be positive, this is now going to be positive, this is now going to be negative. Let's just confirm that on our calculator and see if we get 0 or not. Now, even if you use the original one, it's fine. We want to see something further. Minus. So I get 0. Whether you use the positives, the red signs or the black signs, you get that the probability of A and B, it is equal to 0. Therefore, you say they are what? Events are mutually exclusive, you conclude. Okay? Yes. This is what was required of you. Alright, this question likes to pop up a lot. It is, I think, according to diagnostic reports, is that learners are struggling with this question to understand the concept of probability thereof. Remember, if you do not understand your concept, you cannot apply. All right? Yes. Now, determine the probability of P only, or probability of only C. All right? Remember, probability of only C is probability of C minus any intersection. Any intersection including C. It's fine, I'll explain it. It is further given that probability of A or C is equal to that. Probability of A and C is equal to that. And twice probability of B and C it is equal to probability of A and C. So it means probability of A and C, it is twice probability of B and C. Right? And we have probability of B and C. So what we can do first is, can you allow me to erase this? Allow me to erase this. All right. I'm saying now we are told that probability of twice probability of B and C it is equal to probability of A and C. But now, what is probability of A, B, and C? B and C we don't have, right? But we have what? A and C, so we can substitute thereof. We can say now the probability of B and C. Now, take note, I'm no longer taking the 2. I'm going to say it is what? 2 divided by 5 divided by 2. Can you see what I did? I just divided by 2 on both sides. So if I apply tip and times here, it's going to be more or less something like, it's the same. When you divide by 2, it's the same as multiplying by 1 divided by 2. Okay? Then how much do I get? Then I get probability of B and what? And C as 1 divided by 5. Right? I might need this maybe. I might need this. Let me put it somewhere where it's going to be safe. Okay? I move when am I? All right. Let me just erase that. Now, that was not the answered question, right? Or the asked question. So now, the question is now, determine the probability of only C. This is going to be tricky if you do not know your what your probability principles. So I'm going to simplify this for you. So what I'm going to do is I'm going to say now draw I almost said a Freeboot diagram. Draw a Venn diagram. All right. Now check how many events you have. You have 3 events. Okay. So it means you will be having 3 events, 3 cycles thereof with intersections. Now check which one intersect with which one so that you can see the order of the letters. Now check here. B intersects with A. B intersects with C. Remember, and it is intersection. A intersects with C. So can you see that both B and A intersect with A? With C rather. A and B intersects with C. So it means C should be at the center. What do I mean? I mean now C should be at the center thereof. Because now why? Because now it intersects with both A and B. Both A and B. Right. This is what is happening. Why did I not say A, B, and C? It's because now I have to check the intersections now. Which one intersect with which one? We have this. You agree with me that we have A and C. Probability of A and C we have. Probability of B and C we have here. So if you did A, B, and C in that order, you're gonna struggle. So now let's fill up what we have. Probability of A and C, it is 2 divided by 5. Probability of C and B, BC, it is 1 divided by 5. Remember, I just calculated the off. Now, what is probability of B? Probability of B, I think we have, it is 1 divided by 4. But please take note. All of this is probability of B. All of this. So now when you substitute, it means you have to say probability of this portion, this one, it is probability of B only. All right. So what you need to do is that you have to say probability of B, what you have here, minus the intersection. So if I say probability of B, which is 1 over 4, minus the intersection thereof, the intersection here, which is 1 divided by 5, I get something like 1 divided by 20. Okay? Then now, probability of A only is going to be probability of this portion here, this one, it is A only. But when I include this part, it becomes A. So it means for A only, I have to say what? I have to say probability of A, which is 2 divided by 5 minus the intersection. Minus the intersection, which is 2 divided by 5. So you agree with me that 2 divided by 5 minus 2 divided by 5, it is 0, right? Yes. Now, I'm only left with probability of this portion. I want to explain this thoroughly. This portion, it is probability of C. Okay? But this part here that I'm shading, it is the probability of C only. Why? Because it does not include any part of A, it does not include any part of B. All right? So now how can I do this? Let me just find the probability of C and subtract the intersection. But how can I find probability of C? Probability of C from the fundamentals, we can use probability of A or C minus it is equal to probability of A plus probability of B. No, not B, C rather. This C should be like C minus probability of A and C. Okay? So now what's the probability of A or C? A or C, A or C, A or C. A or C, it is 7 divided by 10. Probability of A. Probability of A, do not check this. You go to your information. It is what? 2 divided by 5. Probability of C, we do not know. Minus probability of A and C, A and C, A and C. A and C, it is 2 divided by 5 also. Then now, can you see that mathematically this and this cancel off? So what does this mean? That means probability of C, it is equal to 7 divided by 10. But probability of C only, which is also denoted as C only, okay, it is equal to what? It is equal to probability of C minus any intersection. So probability of C, it is 7 minus anything that intersects with C here. Anything that intersects with C here. It is 2 divided by 5 and 1 divided by 5. So I'm going to subtract 2 divided by 5 minus 1 divided by 5. And mathematically, when I do this algebraically, I get more or less something like 1 divided by 10, which is also equal to 0.1. I prefer you leaving your answer in this part, in this form. Okay? So that's all. That's all. I know it is a multi-step, but yes, for purpose of understanding, you needed this. Probably your mark will come out here. All right. Then also for finding the probability of A and C. Was it A and C? C and B. This one. I think it also has a mark, but I don't know. But yeah, let's move on. Oh, 10.2.3. Now determine the probability that event A, B, or C do not take part. So now, if they say do not, what you have to do is say 1 minus does. All right. If something, remember, it's either it happens, does happen, or doesn't happen. Right. So when we add this, it should be equal to 1. So now we cannot determine the probability that something cannot happen. All right. Instead, we can say the probability of that something can happen. Then we subtract it from 1. Or what I mean is that you can say 1 minus the probability that something will happen. All right. You cannot determine the probability that something will not happen. Yes, at this stage, yes, you cannot. Okay. So what I mean is that you have to say probability no event. It is equal to 1 minus the probability that there will be an event. So what do I mean? What is a probability that there will be an event? The probability that there will be an event, it is this. This is telling us that we have an event here. All right? And if this probability, all of these things inside the diagrams here means now we have a probability of those events, right? And now, do we have any outsiders? This is what we are trying to look for. Remember, if you have something outside, it means that the event does not occur thereof. So hence I'm saying you're going to sum this, or let's just fill this up. We just found as 1 divided by 10. All right? So I even feel like doing it here. The probability that probability that there will be no event, it is equal to 1 minus probability there will be an event. Where is our event? Or even if you don't want to say there is an event, you can say A or B or C. But let's keep it simple as event. There will be an event. Now, here is the probability that there will be an event. So it's going to be 1 minus what? 2 divided by 5 minus 1 divided by 10 minus 1 divided by 5 minus 1 divided by 20. All right, you can put this inside the bracket to show that you're talking about one thing. Then your answer thereof that you get, it is, let me see, something like 1 divided by 4, which is 0.25. Preferably, I prefer this answer. This is the probability that no event will occur. Okay, that's the probability thereof. Now let's just finish off. Let's finish off quickly. Counting principle, counting principle, counting principle. It says now, 7 friends, which were 4 boys and 3 girls, want to stand in a straight line next to each other to take a photo. All right. In how many? Remember, if they are just standing by their own randomly, we have 7 ways in which they can stand again. Now, 10.3.1 says, in how many ways can the 3 girls stand next to each other? So we want these girls. I'll just call them girls. And boy 1, boy 2, boy 3, boy 4. Let me just say girl 1, girl 2, girl 3. Now we want these girls to sit to stand next to each other, right? So what happens is that I want you to see this. It's either I start with boy 1 and now I have the girls and have boy 2, boy 3, boy 4. Or what can happen is that I can have boy 1, boy 2, and the girls. Can I just call them 3 girls? Then boy 3, boy 4. Then now I can have what? Boy 1, boy 2, boy 3, and maybe have these 3 girls here, and then boy 4. Okay? Then another thing happen. The last part that can happen is that I can have boy 1, boy 2, boy 3, boy 4, and then now the 3 girls. Now, can you see that these girls can sit in 5 ways? This way, this way, this way, this way, or this way. So it means we have 5 factorial ways in which these girls can sit again next to each other. But you have to match. These girls also can be randomized like 3, 2, 3, 1, or 1, 2, 3. So we have to multiply by 3 factorial. Why? Because now they can sit in any way, 2, 3, or 1, or 1, 3, 2, or 3, 1, 1. Right? So this is the answer now. You want to say it is 5 factorial multiplied by 3 factorial, then you'll get your answer thereof. You'll get your answer thereof. Of 720. Now the last question, fast. In the photo, determine the probability that a boy and Lindy will not stand. Remember, will not. What we do, we say 1 minus the probability that will stand next to each other. So now 1 minus, what are the probability that they will stand next to each? Now you're gonna divide by all of them. All right, all of them. So now there are 2 ways in which they can sit next to each other. And since when they are 7, they can rotate 6 times. You can also do what I showed you. So you get your answer as how much? As 5.7. Okay? Yes, this is what you get. Now, how did I get this 2 and 6? Like this. Let's say I want boy 1 and girl 1 to be together like this. Then the other ones can sit randomly. However, no, I already have boy 1, 2, 3, 4, girl 2, girl 3. Okay, so now you can play. Already inside here, I have 2 factorial waiting for me. Then it's going to be multiplied by the ways in which they can sit, what I showed you earlier before. So yes. All right, it's either I can start with, let me do it somewhere here quickly without wasting time. So I can either start with boy 2 and then have them and the rest, or boy 2, boy 3, them, then the rest. Then you'll see that the rows that you'll have, there will be 6. So it is 6 factorial. Multiply by whatever inside the number that is inside, it is 2 factorial. So yes, that's all, and thank you very much, folks, for watching this playlist under May June 2023. Until we meet again, thank you.